Let's try problem 10.6. A boy flies a kite with a string at a 30-degree angle to the horizontal. The tension in the string is 4.5 newtons. How much work does the string do on the boy if the boy stands still, walks a horizontal distance of 11 meters away from the kite, and walks a horizontal distance of 11 meters towards the kite? Alright, so let's just go ahead and draw a picture first. So we have the kite in the air, and let's say the boy is right here holding the kite. That. This will be the kite up here. And we're told the tension in the string is 4.5 newtons. 4.5 newtons. So that's going to be the force that the kite's pulling. And we're asked, how much work does the string do on the boy if A? So let's take A, stand still. So A. So work is just going to be equal to F d cosine of theta. And so if the boy stands still, right, there's no distance being covered, so d is just going to be equal to 0, which is going to mean this whole thing is equal to 0. And so there's not going to be any work done if the boy stands still. So how about part B? Walks a horizontal distance of 11 meters away from the kite. So the kite's pulling in this way, and this boy is walking in this direction. And we're told that he covers 11 meters. So the force that's going to pull this kite, we're only interested in the force that's in this direction right here, this parallel component. The parallel component to his displacement. And so to find this, we're told that it flies at a 30-degree angle, so this is going to be 30. So to find this piece of the force, all we have to do is 4.5 newtons times the cosine of 30. Right, because cosine is just the adjacent side over the hypotenuse, and then I just multiply the hypotenuse to both sides. So I get 4.5 newtons times cosine of 30. And so now we have the force just in this direction, but notice it's in the negative direction. So the work is going to be equal to the force we just found is negative 4.5 newtons times cosine of 30. And then this is going to be force. This is going to be the whole force term. And then just times the distance, which is going to be 11 meters. And then when you put this in your calculator, this comes out to 43 joules. Well, negative 43 joules. Right? Because the force is in the opposite direction of the displacement. And so we have the force pointing in the negative x direction, which makes it negative, and then we have a positive displacement of 11 meters. And so it comes out to a negative number of negative 43 joules. Let's try part C. Walks a horizontal distance of 11 meters towards the kite. So again, we're going to have the same component of the force, right? Except now he's moving in this direction. So he's going to walk this direction 11 meters, and his kite's still going to be pulling on him. So negative 4.5 newtons times the cosine of 30. And then my displacement, I'm saying that he's walking in the same direction, so this displacement is also going to be negative. Sometimes negative 11 meters. And this comes out to 43 joules. So we can see that the work is going to be negative when the distance and the force are in opposite directions, like in the first case over here. And the work is going to be positive when the force and the distance are in the same direction. And so that's problem 10.6.